These barriers protect millions of lives every single day.
Highway barriers begin with raw materials built for impact. Steel reinforcement is the backbone of every barrier. Robots weld structures designed to absorb massive force. Each cage must be perfectly aligned before casting.
This mold will define the barrier's final strength.
Special coatings ensure flawless concrete release.
Steel skeletons are positioned with zero tolerance for error. This concrete is engineered to survive high-speed crashes. This moment determines how much impact the barrier can take. Vibration removes air pockets that could weaken the barrier.
Perfect density means maximum crash resistance.
Every surface is shaped for structural balance. Curing transforms liquid concrete into solid protection. Heat and humidity are carefully controlled for strength. Time is just as important as materials. Technology tracks strength as it develops. Early inspections prevent future failure. Now the barriers begin to reveal their true power. Each one is built to stop tons of moving steel. After curing, the molds finally release their grip. Each barrier weighs several tons.
Even the smallest flaw can't be ignored.
Surface finishing improves both strength and safety.
Every curve is designed to redirect crashing vehicles. This line prepares them for real-wheeled abuse. Hidden anchors allow safe transport and installation. Visibility is critical on high-speed highways.
Every barrier must meet strict highway standards. These structures are nearly ready for the road.
Before highways see them, crash labs do. Designed to absorb energy, not bounce vehicles back. Controlled damage saves lives.
Every millisecond of impact is analyzed.
These barriers resist massive sideways pressure. Sensors reveal how force travels through concrete.
Only minimal movement is acceptable.
Certification means they're ready for public roads. Thousands wait here for deployment.
Next stop, America's highways. Highway barriers arrive before traffic ever does. Each placement is a calculated move.
Alignment here protects lives at high speed.
Once set, they don't move.
Together, they form a silent shield.
Visibility is just as important as strength.
Final checks ensure zero compromise.
At night, they guide and protect drivers. Millions of cars will rely on them. Protection poured in concrete. These barriers face extreme weather year after year. Engineers track even microscopic changes. Freeze-thaw cycles test long-term durability. Road salt is one of concrete's toughest enemies. Protection systems keep steel safe inside.
Minimal maintenance keeps them effective.
Time proves what testing predicts.
Decades apart, the mission stays the same. Quiet strength saves lives without being noticed.
Every barrier follows strict global safety standards.
Design determines how energy is redirected during a crash.
Even small-scale tests influence real-world safety.
Material decisions can save or cost lives.
Cheaper barriers can become the most expensive mistake.
Durability over decades is the true measure of value. Every location demands a different level of protection. At high speeds, precision becomes critical.
In emergencies, barriers create order.
Good engineering works silently in the background.
Most drivers never think about what's protecting them.
But every journey depends on this silent engineering.
Scars prove these barriers have done their job. From factory molds to real-world impact. Miles of protection, built one barrier at a time. Even in darkness, they guide and protect.
Separation prevents the worst kinds of collisions.
simple shapes, carrying enormous responsibility.
When barriers work perfectly, nothing happens.
That's the power of highway barriers.